Hello students, today is 15th of April and we are going to start with the next fluid flow measuring devices which works on Bernoulli's principle, that is Pitot tube. Fine. So we have actually completed Venturi meter and orifice meter. We will get into the next device, a Pitot tube. Pitot tube is a measuring device which is used to measure the velocity of a flow at any point in a pipe or a channel. So if I want to find out what is the velocity at a particular point inside a pipe in which a fluid is flowing, I can use this particular measurement device. An important link between the velocity and the pressure was known by the physicist very earlier, and using this relationship between the velocity and pressure, this particular device was used. If you see, the velocity of a flow at a point becomes zero, then the pressure at that particular point increases drastically. And this is happening because there is a conversion of the velocity energy or kinetic energy into a static energy, that is the pressure energy. So the basic principle by which the Pitot tube work is the energy conversion of kinetic energy to a pressure energy. Here there is a conversion of velocity to pressure. If you see a Pitot tube in a very simplest form, it consists of a glass tube, and this particular glass tube will have a bending, okay, and that bending will be at 90 degree, right angle bending will be there. So you have an upright tube over here bent at a right angle. That's it. Now, how do you place this particular Pitot tube? So in order to measure the velocity, you need to place it against the flow of the liquid. That means if the liquid is moving towards from left to right, you have to keep it in the upstream direction or towards the left direction. The bending of this 90-degree bending part should be facing towards the or against the flow. Towards the upstream it should actually face. If you place it ulta on the other end, it will not sense the velocity. There is no use of keeping this particular Pitot tube on the other hand, that is facing downstream. No, you cannot face it downstream. So the bend should be faced towards upstream. So this is how, okay, left to right the fluid is moving. So you are facing this lower end of your Pitot tube towards the left hand. Now, if you see how the velocity is going to get measured or what is the mathematical equation involved. So before we start deriving it, you have to take two important sections. Section 1, which is just before the opening of the Pitot tube, just away from the Pitot tube, okay, inside the pipe itself, some distance apart from the Pitot tube opening, you take that particular part or that particular section as section 1. And just at the entrance of the Pitot tube, you take it as a section 2. Okay, just at the inlet, you need to take it as a section 2. So, one section and second section is first choiced. After considering section 1 and section 2, you define some of the variables like pressure intensity at section 1, pressure intensity at section 2 or point 2, velocity of flow at point 1 and velocity of flow at point 2. Capital H is the depth of the liquid, depth of the tube inside the liquid. For example, if you see how from the surface or from the top end of the pipe, how much the Pitot tube has been immersed below, okay, how much it is going inside. So that is your capital H, and your small h is the rise of the liquid in the tube above the free surface. So from the upper surface of the pipe, how much, to what extent of the height the liquid actually moves up in the vertical part of your Pitot tube, that measurement is your small h. Okay, so capital H and small h are different over here compared to the other flow measuring devices, where small h was the differential pressure head in orifice meter and Venturi meter. Here small h is not that case, it is the rise of the liquid in the Pitot tube above the free surface or above the pipe surface. Now we apply Bernoulli's equation to section 1 and section 2. So P1 divided by rho g plus V1 square by 2g plus Z1 is equal to P2 divided by rho g plus V2 square divided by 2g plus Z. So your Bernoulli's equation is as same as what you are using it from the so many past videos. Now, if you see the height level of the point 1 and point 2, the height level of point 1 and point 2 is same. They are at the same height. So Z1 will be equal to Z2. So they get cancelled off. And we are considering that the velocity of the fluid will become zero when it enters such a small constraint part of your Pitot tube. So the velocity at the point 2 at the entrance of the Pitot tube will be 0. So V2 is equal to 0. Now we will define capital H as P1 divided by rho g, okay, because this is the pressure head at the section 1. So P1 divided by rho g will be a capital H. P2 divided by rho g will be capital H plus small h, okay, because this second part is connected, your second point is connected to the Pitot tube. So it will include the movement of the liquid, okay, through this whole height. So it will be small h plus capital H. So P2 divided by rho g will be pressure head at 2, which is small h plus capital H. P1 by rho g will be pressure head at 1, which will be equal to capital H. Now you substitute this capital H and small h plus capital H in Bernoulli equation. So P1 by rho g is written as capital H, V1 square by 2g is retained, that is equal to V2 is 0, so it goes off. Z1 and Z2 are equal, they have cancelled it. So P2 divided by rho g will be small h plus capital H. Now you rearrange, okay, take small h, take the equation in terms of small h. Small h will be equal to V1 square by 2g, because your capital H on the left hand side and right hand side get cancelled. So you cancel these two. So your small h will be V1 square by 2g. So what will be the velocity at point 1? V1 will be root of 2gh. So this is the theoretical velocity. V1 is equal to root of 2gh. The actual velocity will be given by V1 actual will be equal to Cv into root of 2gh. So what is this Cv? This is coefficient of Pitot tube. Okay. So we define coefficient of discharge in orifice meter. Coefficient of discharge was defined at orifice meter CD value, right? Similarly, CV value was also defined in venturi meter and orifice meter. Similarly, here also we have CC value was defined in venturi meter. Here we are defining CV. Okay, so CV is the coefficient of Pitot tube. So your velocity at any point will be equal to CV into root of 2gh. Okay, small h. Now, velocity of flow in a pipe by a Pitot tube. Okay, you can arrange this Pitot tube in different manner. For example, if you see the first figure 6.14, you have a Pitot tube and you have a piezometer, a vertical piezometer. It is a pressure measurement device. That's it. Similarly, you have a Pitot tube connected with a piezometer like this way. There is a connection between the piezometer and the Pitot tube. Okay, here they are not connected. Okay, next we have a third case where the Pitot tube and vertical piezometer. This is a vertical piezometer. This is a Pitot tube. This is a vertical piezometer. They have connected with the help of a U-tube manometer. So when U-tube manometer will come, you will have an X reading. X reading and H can be linked. H will be equal to X into ratio of specific gravity minus 1. Okay, where first in the upper part of your specific gravity ratio, specific gravity of the manometer liquid divided by specific gravity of the liquid which is flowing inside the pipe minus 1 into X. That will be your H. Similarly, the fourth arrangement where you have a pitot-static tube, it consists of a two circular concentric tubes, one inside and the other with some annular spacing between, as shown in this particular figure. So you will have two concentric tubes, and the connection between two concentric tubes can be given with the help of a U-tube manometer. So here the H value will be given by this. So in these two cases where they are using U-tube manometer, the H value will be this particular formula which just now I explained to you. So with this as the explanation, this will be your explanation for Pitot tube. small derivation. Please remember the formulae. Okay, you need to remember what is the velocity at a particular point, how to find out. This is very important formulae. Okay, with this I will end this small video. We will see the numerical problems on Pitot tube in the next video, that is tomorrow. Thank you very much.